different problem statement which we had discussed earlier as a part of your linear regression. Now, what we are doing in linear regression, we're basically trying to estimate or create a model to predict or to give an estimate on a continuous variable. So to give an example, how much will a customer will spend? In that case, the kind of a output which is coming out of a model is a continuous output. Like I can say this, the customer is going to spend 1200 units in terms of some currency on this specific product, or 1350 units on some specific product. And that is how the output comes, or that is how we utilize the regression in terms of linear regression. However, when it comes to logistic regression, the problem statement is very different. Now, what kind of problem statement we try to uh, resolve by using the logistic regression? The problem statement here is about whether you should go for something or you should not go for it. It means the decision making problem statement. For example, if I'm talking about a loan approval process, where the output of that whole process is either you are approving the loan for that specific customer or you are not approving it. This can be a problem statement which can be resolved by your logistic regression. Like if you are trying to build a model which predicts or gives you a kind of a forecasting of whether a specific set of customers are going to go for a purchase or not, then this falls under your logistic regression. Now, the kind of a problem statement the logistic regression solves are mostly based on the probability of an event to occur or not. And the output of logistic regression is always a binary. It means it can be 1 and 0. It can be yes or no, or it can be true and false. Now, going a bit deep into logistic regression. So, previously, when we talk about linear regression, we are talking about a linear equation, right? But in case of logistic regression, we're not talking about a linear equation. Rather, we're talking about a sigmoid curve. Now, the curve we're looking at in a yellow color is basically a sigmoid curve, or a kind of a curve which is not linear, or which is not a straight line. But when we talk about regression, we have to transform a sigmoid curve or a non-linear curve into a linear curve or into a straight line curve. Then only we can build a model on top of it. Now, the process in which we transform a non-linear curve into a linear curve is called as logistic, or is called as log transformation. Now we will talk in depth about this specific topic when we take this when we talk elaborately for because there will be dedicated sessions for this specific machine learning algorithm. However, just to briefly understand here, the major target variable here which we try to calculate is the probability. Now probability will be equal to 1 by 1 plus e to the power minus beta naught plus beta 1x. Now the model output which was initially coming in linear regression was the value of beta naught and beta 1. Similarly here also you'll be getting beta naught and beta 1 as a model output. However, the kind of a utilization that you will have here as a part of logistic regression will be different. And again, the probability that I'm going to calculate here, it can be more than it will be having a range of 0 to 1, because probability generally falls generally have a minimum value of 0 and a maximum value of 1. Now if probability is more than 0.5, then this becomes a true output, or the output of the logistic regression becomes 1. If the probability is lesser than or equal to 0.05, sorry 0.5, then the output of your logistic regression becomes 0 or false. Hence, for any kind of a probability number that you receive, which obviously ranges from 0 to 1, you will have only two output. It can be either 1 if it is more than 0.5, it will be 0 if it is less than or equal to 0.5. Hence, the overall output of a logistic model, of a logistic regression model, would always be a binary setup. It can be 1 or can be 0. And depending on this 1 and 0, we will be enabling a model which can help us in our decision making. Now, the next machine learning model that we will talk about is one of the supervised learning. Now, this is called k-means clustering. Now, what is the major use of this specific model? The use is, how can you create clusters out of your data points? For example, I have I have two variables. I have x1 and y1. Now I have income and spend, like you can see in the graph. Now I have data points where the income and splits are being distributed, are being like plotted and as a scattered dots. However, now I want to create specific three clusters so that I can take my business decisions very efficiently or very focused, and that's focused to that specific segment or specific cluster which I'm going to create here. Now, where these kind of things are getting utilized. For example, I am working in a retail company, and I'm dealing with products across my portfolio, and my products are available for multiple income clusters. So I am going ahead and and launching some new promotional activities on top of my retail product or retail product line. And in those promotional activities, I can't take a blanket approach for all my products or for all my customers. Now I need to create groups of similar kind of customers. Now, in those cases, what is the first challenge? Those groups are not already existing. So you have to take few features, basically the customer's income or customer spending ability or some demographic KPI you need to take, and then you need to group the customers depending on those specific features which you have taken in this model. Now, unlike a logistic regression, here you are able to create clusters which are more than two. Basically, your cluster can be three, four, five, and again, what is the number of clusters you are going to select? That depends on your business case, and also there are, depending on the data that you are having, there are various methods where you can get the most effective k value or most effective number of clusters that should be implemented to that specific set of data. Now, the benefit of cluster analysis is it makes us do or makes us take some focused decisions. It means you are running a promotion, but that promotion is not overall. It's basically focused to a set of people for cluster one. So for example, I find like if you talk about this example, the cluster one is set of people where they who are having lesser income and also lesser spend than the other consumers, other customers. Now in this set of people, what I can do is I can go for a higher discount. Why? Because they can't spend more, just because they don't have higher income, hence they can't spend more. So to push my product there, I have to promote it more. It means I need to give higher discounts here. However, when it comes to cluster 2, they're having a good income source, so they are falling in the mid range of income. So in this case, the discount I'm going to give might not be very high. So I can just give a moderate kind of a discount, like I can go for a 20% discount or 15% discount on my product, and the product will still, like get bought because these people are having an ability of buying it just because of the income is high, and also as the income is high, the spending is also a little high from cluster one. When we go to cluster three, now in this case, we are looking at a set of people who are having uh, higher income and higher spending ability. It means these are my premium segment of customers. Now this is where I will need to earn my money, or basically this is where I need to burn less money. It means I need to give less discounts and push more products. So this is how I take my decisions depending on various segments of customers. Now, k-means clustering, as I have said earlier, this is one of the major and one of the most powerful clustering algorithms available in our machine learning industry, and very highly utilized across various industries and various use cases.